In Algebra 2, you did nonlinear systems of equations, which this is. What I'm showing here is a nonlinear system, which means one of the graphs is not a straight line. But you didn't, depending on the class you're in, you may not have gone back into Chapter 3 and did a lot of the linear systems that you practice substitution and elimination and all that. The fact is there is a chapter in this book on systems of equations, and we're going to do it. And so what they have in the prerequisites is not really intended to be, that you know very much about systems of equations. What you understand about a system is it's more than one graph. It's more than one equation. And the solution to the system is, where do these graphs intersect? Like in this graph, how many places do you see an intersection? You see it here and here. So it's actually there's two solutions. So when it's just one graph, we look for the solution on the x-axis. When it's more than one graph, we look for the intersection points. Right? And it comes up, we expect, it doesn't happen often, but even like in a calculus class, if you get into a problem and they say, they give you two things that you don't know, then in your mind you have to think, well, if there's two things I don't know, I need two equations. And that's right there, you're going to have to come up with a system of equations. One won't do it, right? If you have two variables, you need two equations. Three variables, three equations. The atmosphere we model with 7 variables and 7 equations. But because they are partial differential equations, they don't just have one answer. That's why it's a model we can run forward in time and get forecasts from.